Might just take a while.
Yeah.
Nope, seems like we're fine.
Yeah.
All right, should be good.
So I
How?
want to ask a question about the
Yeah,
plan.
go for it.
I want to ask, so with task one, I got like 80% correct.
Mm-hmm.
Like a does print like if I say like start 5 and end 5, so that means that you have to print like five lines, but it doesn't print at the at point 5 and at the end of point 10. It just prints the first 5 lines. So that I must just fix. And then for task 2, it's was saying that it has to catch the first error. So mine does catch the error, but in the try section, or does Sir want us to get the error in the catch section?
So for task 1, the lines are numbered.
Yeah.
So you start at a specific line number and you end at a specific line number. So if you put in 5 and 5, it should only print out one line.
Yeah.
Yeah. Okay. Are you getting that?
Yeah. No.
Okay.
My task one is printing the amount of lines. So for example, if I put 3 and 6, so that means that it will print 3 lines, like 3, 4, 5, 6, or 4 lines. But
Yeah.
it will at the beginning. It won't print at those positions. It will just print from the beginning. So it
Oh,
will.
okay.
So I must just try and fix that.
Yeah.
Uh, but I'm sure I will get marks if I don't fix that. Is that also right, sir?
Yeah, you should get good marks. A possible hint as to how you would solve that
Yeah.
is you can check which line you're on and maybe keep track.
But that does sir understand what I'm saying?
Yeah, I understand what you're saying. So yeah, if you say print lines 3 to 6, which are 4 lines,
Yeah.
instead it's going to print lines 0, 1, 2, 3.
Yeah.
Yeah.
Yeah. It
So
does that.
so what I'm saying is maybe keep track of which line you are on, and when you reach the start of the lines that you're meant to be printing, then you start
Yeah.
printing them out until you reach the last line that you're supposed to be printing, and then you stop printing up lines.
Yeah. So I'll try and do that. And then now for task two,
Mm-hmm.
in my try section of the code, it prints out the first error. But when
Yes.
I'm reading task two, it sounds like it has to print out in the catch section.
So yes. So you need to throw a new exception. That's part of the assignment specification.
Because what helped me with task two is the previous lecture in week one, exceptions and something.
Yes.
Because the one thing that stood out in task two, it says I must make an error for the thing to catch.
Yes. So
Oh,
you can throw a custom exception.
so I have to put like and sir literally gave us an example of it. Am I allowed to say it? Or just three of us?
I can't say anything else.
Okay, so I'll just say that Sir showed us a purpose error in the lecture slide, so I could just basically use that for the to catch the exception. Okay,
Yes, I did show you how to throw a custom error.
I see that. And
Yeah.
for task three, can Sir please give an advice because I don't know how to let the the program look at the word events or error like I don't know if I must say for like is the yeah
Yeah,
I'm not
so when you catch an exception, you say what type of exception, right?
yeah
Then, if you look in the documentation for exceptions in Java, they all have something called get message.
yeah
Then that could be something to consider.
yeah
So I don't know how to say this.
Okay, I
Yeah,
think
yeah.
we can.
Yeah.
Sorry.
No, go ahead.
I was saying so. So I must almost like purposely create an error in the try section and then catch it in the catch section with printing out the error line from the log.
Yeah, so oftentimes when we're dealing with exceptions, if we want to throw a new exception, we can give it a string or a message when we throw a new exception, right?
Yeah.
And then on a separate note, if when we're catching exceptions and we're trying to deal with them, we can print out the error message or the message that the exception has.
Yeah.
Yeah, so that's how exception handling works in Java.
Okay, I see. I have a question on task 3, but I'll ask it tomorrow because I don't want to take up too much of the lecture time.
Yeah, no worries. We'll only start in about 2 minutes. So do you have another question?
Oh, I was going to ask, can sir please give us a tip for task 3? Because task 3, I'm very lost on
Yeah.
how to let the program look for the words notification, warnings,
Mm-hmm.
and error.
Mm-hmm. So there is a hint in the assignment spec
Yes.
talking about a string object has a method called split. That's very similar to the split you get in Python.
Yes.
So if you're reading in a line of values, you can split it and it will give you an array.
Okay.
And the format of log messages is always the same, right? So in the beginning of the assignment, we describe exactly how each line of the log file looks. There's a line
Yes.
number, there is a timestamp, there's the message type, and then the message itself, and they're all separated by spaces.
Okay. Did sir go over this in the last lecture?
I think I talked about it in the consultation session on Friday. I'll have to. Is the consultation available? Can you see it?
So you still didn't upload it.
Okay, I'll upload it this evening, and then you can have a look at them.
Okay, sir.
Um, but the idea would be is that you're reading in a line from the scanner, and you want to look inside that string because the scan.next line gives you a string. You want to have a
Yeah.
look and see what you can get out of it, and then you would just keep track, right? You would start counting.
Yes, sir.
Yeah. So we'll talk about your toolbox. In your toolbox, you have a whole bunch of things. You have loops for going through sequences.
Yeah.
So a whole bunch of lines in a file, you have a loop. Then you have the idea of if statements to check if something is true. Then you had a slightly different version of an if statement, which is called a switch statement, that can match on multiple different things and do slightly different stuff.
Okay,
And
so
yeah.
that's what I was doing. So I don't mind saying. I'll just say what I did first. So I made a switch statement saying, if a line equals to error, warning, or notification, then print out that line. But I kind of did it wrong. Like the code doesn't it's not scanning through the line looking for that word error. So I think now I have to split it like I just sir said now. So I'm gonna try that now, sir.
That sounds like it could work, yeah.
Yeah,
I can't really say much more.
yeah. That's okay. So I can start with the lecture now.
Okay. Let me just see if there are any chats we need to catch up with. I'll have a look in the chat. For the exception message, can I just print out the cannot find log file message using system.out.println? So yes, if you can't find a log file, you just print it out. You don't have to throw a new exception. So someone has sorry, let me just pop out the chat here so I can have a look at it. Actually, I'll keep it there. Someone on the YouTube stream asked, Sir, what are we required to do exactly in the bonus question? So in the bonus question, we talked about program arguments and command line arguments for our programs. And what we want to do is, instead of hard coding the logfile.txt file name, we want to make sure that we can give it any file name or file path at runtime. So when we execute our program, we can give it any log file. So that's hopefully made it a bit clearer. Okay, so I think without further ado, we will have a look at object-oriented programming. Yesterday, I threw you into the deep end a little bit, but today we're just really going to go back to basics and start from scratch, and we'll define things a little bit more clearly. And then tomorrow we'll have a look at the first lecture this week again. So if you felt very lost, yesterday, then that's fine. We're going to go through it a bit slower today, and hopefully everyone will be on board. Did someone have a question?
No, Sam, is that referring to Monday's lecture?
Yes, Monday's lecture. Sorry.
It was a bit overwhelming, but I watched a YouTube video on I think it was going over object oriented.
Yes.
So I kind of have a just understanding of what you're referring to about the classes.
Okay. So we're going to talk about it today as well. We're going to talk about how Java is fundamentally an object-oriented programming language, and that other languages might have object-oriented support or support for object-oriented programming. Java specifically makes object-oriented programming a core feature of the language and something you have to do good Java programming. So we talked about the idea of types for Java variables. So every variable you have is a type. So you had integers, you had strings, you had arrays. Everything has an associated type with it. We also talked about kind of your other tools like if statements, switches, and loops. These are the ones you would be using during your prac this week. That is due on Friday. So if you have any questions, please make sure to ask questions after this lecture or after tomorrow's lecture if you're still struggling, or get in touch with your tutors. But what I really... Yes?
But what did you say is due Friday? Is the prac?
It's the prac that's due Friday, yes.
Sorry, sir. Just glitched out.
Yep. And then what's most important today is I want you to get this idea across, is that everything in Java that is not a primitive type, so something built into the language, is an object or a class. And a good rule of thumb or a good intuition for identifying which is a class and which is a primitive data type is usually they have lowercase names. So a primitive data type has a lowercase name. The ints are, lowercase int. The booleans are lowercase boolean, and so on and so forth. However, the classes and objects in Java are typically named with an uppercase, and I think we call it a Pascal case. I'll talk about, I can talk about kind of style guides later on, but so something like a string, which starts with a capital, a string object is actually a class, right? However, an int is just a primitive data type. And the main difference here is that with integers, they're very well understood. The data structure is very well understood, but also very simple. However, with classes and objects, we can make our data structures quite a bit more complicated. So they can have things called attributes, which contain data. So they can have integers, strings, and things associated with them that contain data. And then they can have things called behaviors or methods that can act on the data or can do a whole bunch of things, right? So the main distinction and the thing that I want you to think about when you think about objects is that they're more complicated but also more powerful ways to organize and structure data together. And object-oriented programming is a mental tool. It's a programming paradigm that we use as programmers to make programming a little bit easier, especially when we're working with very complicated programs, right? So it's a way for us to think about objects and so forth. Now, what I mean by Java is an object-oriented programming language is something where if we went back to possibly the first Java program we wrote, we had a look at Hello World, we can see that it is a public class. So the second word you ever wrote in Java would have been class. It might even have been the first if you didn't make it a public class. So this is what we mean by object-oriented programming, and that Java is an object-oriented programming language. Everything in Java that we write is a class. Later on, we'll look at something called interfaces, which are a slightly different idea, but don't worry about that too much. And then this over here, this public static void main with the string of program arguments. If you are wondering about the bonus question, this is a hint right here for the assignment, that is. But this public static void main method is a method of the class Hello World. It is a behavior of the class Hello World. Okay, so this is what we mean. You have been doing object-oriented programming, you just maybe weren't as aware of it until now. Then, when we looked at using input from a scanner or taking input, we had a scanner variable. However, the type is scanner, and it's got an uppercase letter, so we get an impression that this is actually a class. And we created a new scanner and gave it some sort of thing to read from. Okay, this is a special method or a special function we call a constructor that we'll look at as well later on. But we couldn't just assign it some value. We had to use a new keyword. We're going to look at that in tomorrow's lecture. And we had to create it from a blueprint, from a class blueprint. We created an object. Then on the scanner, we could call these methods or these behaviors on that scanner by saying scan dot and then calling the method name. Is everyone with me so far? Let me just double check the chat. Okay. Is everyone fine with that? Everyone with me? Okay, so we can move on. All right. So this is okay, excellent. So just have a look here. Today we're going to be talking about basic definitions. We're going to talk about kind of how you structure and compile. That'll come in a bit more with polymorphism and inheritance. And especially we're going to look at how do we define the methods, because they're quite useful, and attributes. We touched on a little bit about objects and references yesterday when we looked at the instance of an object versus how we created them, or just a class reference. We're going to touch on something called the this keyword, constructors, as I mentioned, inheritance, polymorphism, and then somewhere in here we'll talk about the concept of a static class. So we're slowly revealing all of the hidden magic that Java is doing. So static is something you see over here. We called a method a static method, and that's another special keyword, and it's a special behavior of Java. But don't worry about it now. We'll talk about it later once we've done inheritance. So this is just to give you an idea. And hopefully by the end of today, you should be able to define a class. You should be able to hopefully define a method. Okay, so these are the two things we're going to be ticking off today. So for an example, let's say we create a new class called a greeter. And a greeter's job is to print a message when we tell it to say hello, to greet someone. Okay, so we would write it with public class greeter. And then we would have private string message equals hello world, and public void say hello, and that would print out a message. Okay, so some key things to note about this class here. We don't have a public static void main method. There is no public static void main method. Okay, so if you compile this program, it will compile if you wrote the correct syntax, but you are unable to run this program because you do not have a special main method called an entry point that the Java compiler or the Java.
Sorry, there might be a delay when I'm speaking, so sorry
Yeah?
for cutting you off. So basically, we like creating a variable, but with like classes. So it's like it looks like you made a variable said hello world and you're printing it out, but not you didn't say string equals
Yes.
message. You made like a class saying a
Yes.
message.
So yes. So you're getting the idea that in Java classes are types, and you can use the types, so a class, to define a variable. Okay, so a class is just a blueprint. It's a type, it's a blueprint, and then you can create something called an object, which is an interactive, a thing you can interact of that type. Does that make sense? So we're just defining our own special thing.
So can you please say one more time?
Yeah, so in Java, classes are a type. So you had the idea of integers and booleans and strings. A class, it behaves like a type. A object that you can create from a class can be interacted with. So in this case, we're creating a special type called a greeter that has a attribute, a message that is a type string that it stores, and then it has a behavior that we can call called say hello. And when we call say hello, it prints out the message. So if you look over here with scanner, essentially we can replace scanner with greeter and next line with say hello. And that's how it will look. So I think we have it on the next page here. So over here, you can have a look. We create a new greeter and we create a greeter object. So this is the type. We're saying this class is the type of this variable, and that this variable needs a new instance or an object of this type. Does that make a bit more sense?
Yes, sir.
Okay. Let me just double check the other chats. Yes, sir. Okay. So this is the main power of object-oriented programming. We can create these complicated data types that have certain behaviors. Okay. It's going to get really crazy when we do polymorphism and inheritance, because we start composing really complicated data structures, but they also make the programming very interesting and efficient. So the main point that I want you to get over here is that we don't have to have a main method inside of a class. So we don't need to have a main method. This over here is a attribute. So this is an attribute, think like that. And then this over here is a method. Okay. So a class consists of attributes and methods, and it doesn't have to have the special main method. However, if we want to then use this class that we created as part of a program, we will need to write a main method eventually. And the main method is like the front door to your program. This special main method, exactly as it's written here, is the front door to your program. So you might have a whole bunch of extra classes in your program. They might all be different, have different behaviors and different data, and there's a lot of wonderful, complicated stuff you're doing. But you need to enter your program somewhere, and in Java, that is this main method. So any class, but usually you'll only have one class. Any class that implements this main method can be run as a Java program. Is everyone okay with that idea?
Could you just repeat that one more time?
Yeah. So any class in Java that implements the special main method can be run as a Java program. Any class that doesn't implement this main method cannot be run directly as a Java program, right? So that's when you call Java and you give it the class name.
Yeah,
Right,
I
so
see
that's
it's
when you
pretty neat
sure.
without
that's when you
the
call
print method,
Java
the
and you give it
system
the
printing.
class name. Sorry, ask again.
Sorry, like when you print something, you use the system dot out print ln. How come you're not using it here and the output says hello world?
So that's because here in the greeter method, there we call system.out.println. Does that make sense?
Yes, sir.
So we've
Oh, so like
yeah.
so like so technically these two classes.
Yes. So the say hello class makes use of the greeter class to do a bunch of complicated stuff, but all you need to do is call a method. So it simplifies your main program.
Sir,
Yes.
it's like calling someone directly and indirectly.
Yes, exactly.
Using a
So
method, you call someone directly, and then using a class, you call someone indirectly.
yes. So if you had a business, you have different roles. So someone's an accountant, someone is a salesperson, someone is the the receptionist. You have different people to do different things, so that any customer that comes in doesn't have to talk to one person and talk about all the stuff like sales and accounting and everything. Instead, they can be sent to different departments to talk to different people. It simplifies your business process. Okay, in programming, this is an idea called abstraction. We're making things a little bit more abstract so that they're a bit simpler looking and easier to program. So, if we change that program, sorry, is everyone okay?
In the same sentence.
Say again.
Joke saying you say the code is abstract, but then at the same time you said it's simple.
Yes, it's the idea of kind of like the E equals mc squared physics equation. It's a very simple looking equation, but there's a lot of underlying concepts and understanding that goes with it. So you might have a very complicated system, but when you're programming it, it's relatively straightforward. You can this kind of abstraction also lets different people work on separate parts. Okay, is everyone okay with that? Everyone on board?
Yes, sir.
Okay.
Yes, sir.
All right. So let's have a look at this program. Now we create a new greeter object. We say greet.message equals goodbye, and then we call say hello. Any guesses what happens? You might want to look at this.
So doesn't it just print hello?
Yeah, so we'll have a look.
So it's not gonna print it because we never made a private message saying goodbye.
Yeah. So you hit on it there. The message attribute is private. So over here, we called it a private string message. So actually, we will get an error. The Java compiler will not let us access a private attribute from outside of a class. So over here, this is not inside of the class. We're in a different class here called say hello. And we're trying to access the message attribute. This is not allowed. So this is one of the big benefits of object-oriented programming. We can strictly control how the information is accessed. This is the idea called encapsulation or information hiding. So with encapsulation, we can control who gets to access and change the data and how they get to do that. So you can imagine with financial systems, if you had an object for someone's account, you don't want just anyone to be able to edit the total amount in the bank account, right? It's a security issue. So this is where object-oriented programming and encapsulation comes in, or information hiding. So because we have called it a private attribute, this is the access modifier. Because we have called it a private attribute, it is not accessible to anyone on the outside, only internally. So this access in here is fine because it's part of the class itself. It's within the class. So within these brackets, we can access our private attributes, but outside we're not allowed. Does that make sense to everyone?
Yes, sir.
Okay. So now we're going to look at defining class methods. We've looked at kind of attributes a little bit. Now we're going to look at methods. Methods are very useful if you want to break up different sections of your code and kind of, especially the reusable sections. You can just write a method and then call that method to make it a bit easier and a bit simpler. So a method is defined within a class. We use a access modifier, we have a return type, and then a method name. Okay, so we're going to look at defining methods that return a value. For now, void is what we'll use. Void just says that we're not returning anything. The method just kind of does something. We'll look at defining methods that return a value in a bit. That is also where classes are quite useful if you want to return more complicated data. But for now, let's look at method declaration. For now, we can say it is a public method, so it's accessible outside of the class. If you only wanted to use it inside of the class, you would change it to private. There is a third type of access modifier called protected, but that comes in with inheritance later on. Then we usually say it's a static. There are some rules when we call a method static. Then we have a return type, the identifier or the name of the method, and then a list of parameters. Sometimes you call them arguments. For now, we'll call them parameters. And for each parameter, you need to specify the type of that parameter and give it a name. And then those parameters are all separated by commas if you have more than one. So the main method, it's a public method. It is static. We'll look at that implication later. It returns nothing. Its name is main, so the method name or the identifier is main. And then it takes a single parameter, which is an array of strings called args. So inside this method, you have a already declared variable called args. Okay. Is everyone with me on that?
Yeah.
Okay.
With you.
Okay, excellent.
Is
Yes?
that just explained to us a normal code?
Yeah. Say again? Yeah. So this is how we declare methods. And it can change a little bit, so we'll look at it.
Explain to us in normal
So
code
this is
and
how. Sorry, ask again.
methods basically your own code.
Yes, you can create your own functions. It's a way for you to break it up and make it a bit simpler. So we'll look at where it's useful. Is that fine? Can I move on?
Yes, so you can move on.
Excellent. Okay. So another.
Sorry, there's just a big delay with Google Meet.
Yeah, sorry, that's fine. What might be useful is if you mute the stream and you just have the Google Meet audio on. That way the slides might be delayed, but at least the voice will be.
You can do that, but then it goes out of sync with the slides.
Yeah. Okay. Well, it's fine. We'll talk about something called method signatures, and hopefully everything will be okay. A method signature, and you can imagine why you would need a signature. A signature is a way to keep things unique, hopefully. So when we have people signing contracts, we will use their signatures, and your signature is meant to be unique to you, right? So this, in the same way, a method signature is the access type, the name, and the parameters list. So as long as one of those three or more, so one or more of those three things are different, you can have multiple methods that are named the same, or multiple methods that have the same parameter, or multiple methods that have the same access type. But you can only have one method with a specific access type, name, and parameter list. Okay. So this idea that we can call multiple methods by the same name, but perhaps have different parameters, this is an idea of method overloading. So it's called method overloading. Later on, when we do inheritance, we will talk about something called overriding methods. So be very careful when you're learning or studying this. Method overloading is when we have multiple methods with the same name, but a different type and number of parameters. Okay, so the arrays.sort class has the same method name, sort, but it has a whole bunch of different implementations depending on what the type of the parameters is, what the type of the array is that it's being passed. Okay, so the key point here is that overloaded methods have the same name but different signatures. So later on, when we look at inheritance and all of this, we will touch on overloading again. We'll also discuss overriding. When we discuss the two, we'll make sure to be very clear about which we mean. Okay. So this is something interesting for you to have an idea of. You should know what a method signature consists of. So if I were to ask you, what are the three things that that make a method signature unique? And then you need to know what the requirement is for overloading a method. And very specifically, when we overload, it's the same name, but it has different parameters, okay? Or a different parameter list. So those are the two key takeaways for method signatures and method overloading. So if you look over here, this is an example. If we want to print a primitive array, we can use method overloading so that we just call print array and give it the array that we want to print. And so on a programming perspective, we can just call print array and give it whichever array we have. And we can do this for any different type of array listed here. And it gives us a very clean interface instead of calling print string array, print int array, print float array, print double array, print char array. Right? Now it's just a single method called print array, but we have overloaded it with different parameter types. The parameter is still called the same, it's called array, but the type has changed. It's also important to know that we need to implement each of these methods. So every time we overload, we need to implement that method. Okay, so we need to add code for each of these to then print the correct array, or print the array as need be. Is everyone with me?
Sir, is a primitive array different to an array list?
Yes. Yes. So an array list, we can quickly test your knowledge. An array list looks like this, right? Array and then list. Is this, if you had to guess, would you say this is a primitive type?
So the voice is out of sync with the slides, so I'm gonna wait for you to.
So
Okay.
I think I need to recap on primitive, and I think
Okay.
reference type.
Yeah, so an array list is a class. It's a more complicated data structure. Whereas a primitive array is just the square brackets at the end of a type. So an array list is not the same as a primitive array. An array list has extra methods like get or find or index of, whereas a primitive array has next to no methods attached to it. It has an attribute .length, and that's about it. Okay. So you can see how an array list is a lot more powerful and easy to use, or more flexible to use, than a primitive array. And as such, it is more than likely a class. Well, I'm telling you, it is a class. So you can see the benefit of writing our own classes to use as types. So what we could do is we could overload this method once more to take in an array list. Is everyone with me?
Could you repeat that last part one more time?
Yeah, so we could overload this method over here once more. We can overload it once more, and then we would say in our parameter list, we would still call it array, but we would have a array list instead.
Okay, so that makes sense.
So even though they're different types, we can still overload the method to give us that clean interface. All right, so the next thing, so that's methods. We're going to briefly talk about a concept called scope. Did you touch on this with Python when you used global variables?
Yes, we did.
Okay, so in Java, the scope becomes even more important because there's the idea of a class scope.
So we were introduced to global variables, but we're not so into it. We just basically use it for the function parts.
Okay, well, this is the same, but in Java, we're adding an extra scope. We're adding a class scope. So in Java, we have the idea of a class scope and the idea of a method scope. And then whenever you have these curly brackets, you are entering another scope, right? So you can think of, if you were to stack these curly brackets inside of each other, that is essentially the scope. So this if statement, everything in here is in the scope of the if. So that counts.
What's the point of all different coding languages if like literally like Python, Java, and I guess like C++, like they're all similar ways of coding, but just they're just structured differently. So how does
Yes.
it, or like how is the one code different from the other?
So when you get more experience, well, you're already getting the idea. Certain languages kind of force you to write in a specific way, and they have different trade-offs. So Java is heavily object-oriented, and it's compiled to Java bytecode. And so the Java bytecode runs on a whole bunch of different devices. But there's a performance trade-off. However, something like C++ is a similar syntax, but object-oriented programming is optional. The trade-off there is that if you want to run it on Windows, you have to compile for that specific architecture. So different CPUs, you will have to compile a different version of your program for each CPU architecture you want to run on. Then something like Python, object orientation is optional. The syntax is very flexible, but it's an interpreted language. It's not compiled. So it's a little bit slower in execution, although that's changing a little bit these days. So the answer is different programming languages actually work for different use cases, different applications. So a lot of the machine learning libraries in Python, the really fast mathematics tensor methods that they need are actually written in C++, because they need to work directly on, as fast as possible, on the GPUs. However, then you get the benefit of Python, where it's a very nice scripting language. So ultimately, what you should be aiming for in this course, and when you move forward with programming, is that you have the skills, the general toolbox, knowing what classes are, knowing what ifs and switches and for loops are, knowing all those things and having an idea of types. You have this general toolbox that when you go to learn another language that's maybe for a specific use case, you can pick it up quite easily. So yes, the difference comes in what you need to use it for. You can make any programming language do almost anything, but it's just which one is most appropriate. Does that answer your question?
Yes, sir. Like I was just a bit confused in the beginning too, like why like we're learning loops, variables, for loops, while loops in Java, which we did the exact same in Python, but Python was just a bit more simple. But I kind of see what you're saying now, sir.
Yeah. So hopefully, if I were to give you just a cheat sheet on what loops, if statements, variable assignment, and everything looks like for, say, the Kotlin programming language, you should be able to pick it up relatively quickly. Because you already know what a loop does. It doesn't fundamentally change. You already know what an array is. It doesn't fundamentally change. It's just the syntax changes. Is everyone up to speed with that?
Yes, sir.
Okay. Any other comments? No, we should be good. All right, then let's finish up so that if you have questions about the assignment, we can handle those. So this is the idea of scope. We're just adding a new scope called the class scope, and everything that is private is only accessible in the class scope. Everything that is public is also accessible outside of the class scope. Okay, that's the main idea. So now we finally have some more formal definitions. A class defines a type of object. An object is an instance of a class. So the word instance there is the operative term or the key term. Attributes are variables that belong to a class or object. The reason why we say class or object is because in static classes, things can get a bit different, get a bit weird. These attributes can be private, public, or protected. Don't worry about protected for now. The values of the attributes give the object a state. This is something we'll talk about tomorrow again. And then the behaviors of an object, or the methods, you can also call them methods in this course. I really don't mind. The behaviors of an object are the actions it can perform. They're defined as methods in Java. Okay. Different programming languages have different terms for things. Some call them procedures, some call them methods, some call them functions. Python, they call them functions. Java, they call them methods. Okay, but they're the behaviors of an object. All right. Then the other definitions are that encapsulation is the practice of controlling the access and visibility of data within a class or object. So when we use private, this is part of encapsulation. It's also called information hiding. Inheritance is something we'll touch on next week or maybe the week after, depending. It's a way for classes to acquire the attributes and behaviors of parent objects. So we start to compose more specialized classes. Don't worry about it too much, but there's this idea of classes organizing into a hierarchy. But don't ignore this definition for now. Don't worry about it too much. And then polymorphism is yet unknown knowledge for us. So we're going to touch on that much later. So I'm going to post the lecture and the code samples up on eCanva as well. What I want you to do is write a method or a behavior for the greeter class called sanitize. And call it after you call say hello. And then what it needs to do is to print out you have been sanitized. Okay. Then I want you to think about conceptually how to design a class for an object that will represent a person. And then ask yourself, how would you design a class for someone that is a grandparent or a parent? What kind of attributes would you want? What kind of data needs to be associated? These tasks here, don't do any coding. Just think about it, maybe do like pen and paper, try to apply the UML diagrams from Monday's lecture. We'll go over UML again tomorrow, now that you have a better foundation on objects. Okay, that's it for this lecture. So I'll open it up to questions. Well, we've still got about 10 minutes. So I'm going to open it up to questions. Feel free to ask. But for now, I think I'll stop the stream just so that we don't extend it unnecessarily. But yeah, otherwise, if you are going about your day, enjoy the rest of your day, and I'll see you tomorrow for another lecture.
So I have a question about the assignment.
Yes.